module exercise 1, and that will solve from today. Okay, first before this we start, first you tell me am I audible or not? You please comment that. Am I audible or not? Yes, please comment that. Yes, if it is audible to all of you. Okay, then now we'll start. Okay, so first we'll do one thing is that any module you take, we'll start from the module. And how do I discuss that? I'll say the question number. If you have doubts, you will say yes, I have a doubt sir on this question number. You write the question number in your chat box. Understand? That's how we'll discuss this module. Okay, so first we'll start from the. Okay, so open module 3. All people open module 3 of KCT as well as NEET, and in that open the page number 5. Open the page number 5. Have you opened the page number 5? Okay, once you have opened the page number 5, then if you have doubts, I'll say the question number. You will say if you have doubts in question number or not. Okay, yes. So now you have opened it. Okay. So now question number 1. Do you have doubt? Question number 1. If you have doubts, you write the question numbers. Okay, whichever question number you have doubt. First we are going through page number 5. Question number 1. Do you have doubts? Question number 1. Okay, question number 2. If you do not have doubts, we proceed to question number 2. Question. Okay, doubt in question. 12th question will go one by one. Okay, we'll go one by one. Don't jump. Okay. If I say question number 1, you think about question number 1 only. Then we'll do question number 2. Because doubt in question number 1. Okay. Samita has a doubt on question number 1. Question number is the percentage of nitrogen in urea is. Okay, the percentage of nitrogen. So they are asking percentage of nitrogen. This is question number 1. Okay, page number I'll write module. This all we are solving module 3 KCT and NEET, and the page number goes as 5. We are solving question number 1. They are asking percentage of nitrogen in urea. So now you should write percentage nitrogen means what? Mass of nitrogen divided by total mass of urea into 100. And if you remember urea we did. Remember urea? I gave urea formula also. If you remember urea is NH2CO. NH2. This is urea molecular formula. Can you tell me the molecular mass of urea? How do I solve? So I have written like this also. N2H4CO. Remember? Yes. So now 2 into 14 plus 4 into 1 plus 12 plus 16. When we add all of this, we get 60. Remember? This is molar mass, same with molar mass of acetic acid. Right. So this is 60 gram per mole. So this is total mass of urea. This is in one molecule or 1 mole. Okay. In that, how much mass of nitrogen? In this, how many nitrogen are? There are total how many nitrogen? There are 2 nitrogen. So 2 and 2 also. Okay. So question number 2. Doubt in question number 2. Sir, voice not audible. Is it audible now? Okay, is it audible now? Okay, so question number 2. You don't have to write answer. It's still not audible. Okay, question number 2. You have a doubt. Anand Raj, you have a doubt on question number 2. Okay, question number 2. The empirical formula of a compound is CH. Its molecular weight is 78. The molecular formula. This is very easy question. If you remember, last class only I told you empirical formula and molecular formula, right? So, empirical formula they wrote, right? Empirical formula they wrote. So, empirical. This is question number 2. Empirical formula is equal to CH, right? So, can you tell me empirical formula mass? How much mass will be empirical formula? Can you tell me? Yes, if you are able to tell me empirical formula mass, right? So, okay, so empirical formula is 12 plus 1. Total equals to 13, right? And they are given molecular mass also, molecular weight. So now, if you remember, you can find out this value. Molecular formula is equals to what? Empirical formula times what? Times n, right? So now, we need to find the value of n? N equals to 1. Last class also I told you, molecular formula mass by empirical formula mass. Empirical formula mass is this. Do you have molecular formula mass? Yes, it is given in the question. It is given. How much it is? It is 78 by 13, which will give you 6. So molecular formula is equal to what? CH times 6, which is equal to what? C6. H6, that is your answer. This is which option? This is D option, right? Able to get the answer? Yes. So, whichever question you are having a doubt, please make sure that you are copying it properly. Okay, I am giving enough time to copy also. So, while I am writing on the board also, meanwhile, simultaneously you also copy. So that you have a solution with yourself. Whenever you require a revision, you can do it on a later purpose. Okay, now question number 3. So one guy has asked me question number 3 also before. Sir, sound is low. Okay. Devidas has asked question number 3. Anyone else who wants to solve me question number 3? Okay, now we'll solve question number 3 also. 4 gram of caustic soda contains same number of atoms. So this is a very good question. This will clear your concepts. Okay, so this is question number 3 now. 4 gram of caustic soda. 4 gram of caustic soda. Now caustic soda, I told you with there also in the first class we did caustic soda is NaOH. Its molar mass is 40. So can you find moles? Moles equals to given mass by molar mass, that is 40. So how many moles? 0.1 mole. But what is the question? Contains same number of sodium ion. This is moles. Moles of NaOH. They are not asking moles of NaOH. They are asking moles of Na plus. Contains same number of Na plus ions. They are asking ions or atoms. So first you need to find out this is moles. You need to convert this into atoms or molecules. So what we'll do? We'll multiply by Avogadro value. Avogadro value is denoted by Na, right? 0.Na. Now, this is molecules of NaOH. Now, question is Na plus. In one molecule of NaOH, how many Na plus? So, the answer is single, right? So, it means if you have 2 NaOH molecule, how many Na plus you have? 2. The same value. So now I can say 0.1 Na ions of Na plus. This is the value. Now this value will match with any one of the 4 options. Now we have to try each one of the options. Ions as are present in option A. What is this? 10.6 gram of Na2CO3 given mass by molar mass, right? So we'll get how many moles? We'll get again 0.1 mole. But of whom? Of Na2CO3, right? Once you get Na2CO3, then I will convert it to molecules. So basically, whenever you have this one concept is there in this case, whenever you want to convert a moles into atoms or molecules, what we have to do? We have to follow this path. Always follow this path. First you find moles. First you find, this is an important step. Okay, first you find moles. Once you find moles, then you convert this moles into molecules. Right? Once you convert the molecules, convert into atoms. And now one more step also they can go. Atoms, if you remember atomic structure, which is our next chapter also, in atoms, what are they present? In atoms, we have subatomic particles. Subatomic particles are what? Subatomic particles are electron, proton and neutron. It means inside atom there are those. So then we can find out electron, proton or neutron. So this is the path we have to follow in order to find moles, molecules or atoms or electron, proton and neutron. Right now they are asking ions. Ions goes in this category, atoms. Okay, that's why first I find moles. Now I'm going to convert this moles into what? Into molecules, right? So how many molecules? So 0.1 Na molecules of Na2CO3. Now from molecules I want to find sodium ions. Now to find sodium ions, if you remember, this is 1 mole. Now the point here is 1 molecule of Na2CO3. Listen very carefully. 1 molecule of Na2CO3 will give you how many Na plus? So the answer is 2. It will give you 2 Na plus. Right? As it gives you 2 Na plus, if I have 10 Na2CO3. So how many Na plus? 10 into 2. Right? 20 Na plus I'll get. It means whatever I'm having, X means X molecules of Na2CO3 will give me 2X, double. Because why? Because of this 2. Right, so now, so total we get 0.2 Na, because multiplied by 2, Na ions of Na plus. Then this is option A. Like this we'll do option B also. B option is 58.5 gram of NaCl. Now we can increase our speed, right? 58.5 given mass by molar mass. So how many moles? 1 mole. 1 mole of NaCl. So how many molecules? 1 into Na molecules of NaCl. This gives you 1 Na. It means how many ions of Na? So we have 1 into Na ions of Na plus. This is option B. Now we have option C. We'll solve. While solving option C, sir, sound is very low. 1 minute. Sir, I don't have module. Sahib Khan, you have to check your WhatsApp group or Telegram group. The PDF of this module is there in WhatsApp and Telegram group. Sir, sound is very low. Now it's fine, right? Okay. Sir, not audible. It will come. You wait for time. Okay. Okay, now we'll see option C. Option C is 100 ml of 0.5 molar Na2SO4. Now there is a good point. Okay, now there is a point of 100 ml of Na2SO4. With this one, word is there. What is this word? Who will tell me what is this word? First you tell me this word. First you tell me what is this M. What is this M stands for? Who will tell me what is this M stands for? and moles is there. Moles is here, right? So what is the formula of moles from here? So moles formula will be moles equals to, if I want to find this value, this will go to multiplication there. So I will be able to write molarity into volume in liters. So there is a formula of moles. Now from this value I can have moles. Moles formula equals to what? Molarity into volume. Volume must be in liter. Right. Okay. Now, so you copy these two formulas. These formulas are very important. Okay, copy this formula now. Right now, copy this formula. This formula will help you in a lot of many questions. Okay. Copy this formula. Then moles equals to molarity into volume. Now you have copied it. Then you see here. I wanted to find moles. Correct. And to find moles, they did not give me any three formulas. Which formulas? In the beginning, first class, I told you. What are those things? I told you something as given mass by molar mass. Then I told you number of molecules divided by Avogadro value and volume of gas at STP divided by 22.4 liter. But none of them is given. So there is fourth formula. Moles equals to molarity into volume. So now molarity. Molarity is 0.5 into volume 100. But there are written volume in liters. Volume in liters. But this volume is in ml. If this volume is in ml, I need to convert it into liters. So how do I convert in a volume into liters? From ml into liters, I will divide by 1000. So I'll divide by 1000. Correct? Yes. Then if you solve this, these two zero will get cancelled. This will become 0.05 moles. 0.05 moles. Now moles of Na2SO4. Moles of Na2SO4. Now moles, I will find molecules. So how many molecules? 0.05 Na molecules, right? Na molecules. Now from these molecules I need to find Na. Now you remember molecules of Na2SO4. So one molecule will give me 2 Na plus. One molecule will give me 2 Na plus. So 0.05 will give me Na into 2, right? Which will give me 0.1 Na ions of Na plus. Okay. Now this is option C. Now we'll look at option D. Now what option D says is? What option D says? 1 minute. Okay, option D says 1 gram equivalent of NaNO3. So now we'll concentrate here one more formula. That formula is equals to normality. Normality equals to number of gram equivalent divided by volume of solution. It must be in liter. It must be in liter. So now I can write one more formula. If it's in ml, so you will write this ml into 1000 as you have done for molarity. But do I have a formula for gram equivalent? So gram equivalent is equals to normality into volume must be in liter. Okay. But one more formula for gram equivalent comes as gram equivalent equals to moles into n factor. Moles into n factor. This also you copy. Okay. Moles into n factor. So the moles equals to what then? Moles equals to gram equivalent divided by n factor. That is the fifth formula for moles. You see I have written fifth formula for moles also. Gram equivalent by n factor. Now we will write something for n factor also. So moles you know. We should know what is n factor. N factor for acid. For acid, it is equals to number of H plus ion. Okay. For base it is equals to number of OH minus ion. charge present on total cation or anion. Total charge. Let's take an example for HCl. HCl is an acid, so it goes to this category. Acid number of H plus. How many H plus it will give? Tell me how many H plus it will give. Are you with me now? So tell me now. How many H plus it will give for HCl? Reply fast. How many H plus HCl will give? One, right? Nitesh has given the correct answer. So HCl is 1, right? HCl. So 1 is the N factor. 1 is the N factor for HCl. If I ask you for H2SO4, what is the value of H2SO4? Tell me now. For H2SO4 also. So Abhishek Dubesar is also replying. Good. People are learning many things now. H2SO4. Tell me now for H2SO4. H2SO4. Yes, Nitesh is winning this race now. So H2SO4 is 2. Now we do, this is for acid, right? If I get base NaOH, how many? Now this is base. Now I will not ask for H plus. I will ask for OH minus. I will ask for OH minus. Now OH minus for NaOH will be how many? Tell me now. Yes, many people have given correct. Now for NaOH. Yes, Sanjay has given now correct answer. So NaOH is 1. This is easy, right? One more will do. CaOH whole twice. If you have given this, you have understood the concept. Give me for calcium hydroxide. Calcium hydroxide. Calcium hydroxide. So now Abhishek Dubesar has got it wrong now. Okay. So CaOH whole twice is 2 because it has got 2 OH minus. Now we'll do for the third category, which is important. What is this category? Salt. Salt means total charge present on total cation or anion. So one salt I'll take. NaCl. Now can you tell me, is it acid or it is base? So it is neither acid nor base, right? Then what it is? It is salt, right? It is salt. So whenever it comes to salt, first thing you should do is you should break it. You should break this compound. How do you break? You will write like this, Na++ Cl minus. Now when you write like this, number of atoms should also be same. Okay. Then you find out total charge present on total cation. How many cation you got? You got one cation. Na plus Na. How many anion you got? You got one anion also. And total charge, so one cation only. And total charge on cation is 1 plus 1. Total charge on anion is minus 1. The magnitude must be same. There's a point. Magnitude must be same. So the N factor here becomes 1. Now we take another salt. CaCl2. Now CaCl2, when you break CaCl2, how do you break? Break this compound. Then I'll see. Break CaCl2 now. Break CaCl2. Guru, Prithvi and Ayush Roy, the answer is not 0, okay? The answer is 1. Not Cl2. Arjun has done a mistake. Ca2 plus. This is wrong. Now you see like, first you need to understand what calcium charge will be there. Okay. Yes, Srinivas has got it completely correct. Nitish also has got completely correct. T and Jayanti has got it Cl minus wrong. Darshan has got it So calcium has got two charges. So whenever you break CaCl2, whenever you want to write Ca ion, Ca will get Ca2 plus. This is important. Ca will always get Ca2 plus. Then you will write plus. This plus is because I want to add cation and anion. This plus is charge on cation. Then I want to write Cl. Correct. The Cl is Cl minus. Cl is always Cl minus. But how many Cl there are? There are that many Cl. How many? 2. So the correct breaking is Ca2 plus plus 2Cl minus. Right. Now you see your point here. How many cation total? 1. How many anion total? 2. Right. 1 cation, 2 anion. The point here is total charge present on total cation or anion. So total charge, total cation, only 1 cation I got. How much magnitude? 2. Total charge present on total anion. So total anion is 2 and total charge present on total anion is minus 2. Magnitude is 2. Both magnitude must be same and we take magnitude wise. 2. We'll not add them, we'll simply write 2. Now the next one is, try this question. Al2SO4 thrice. Break this, write it here and tell me what is the N factor in chat box. Okay. Do now. Okay, so yes, now who has written it correctly? Yes, most of the people has now corrected correctly. Okay, I agree there is a little bit of buzz sound, so you please concentrate on my sound only. Okay, don't be concentrate. If you try to concentrate on my sound only, then you will not feel the buzz sound also. You have to be little bit increase your concentration level. Okay, there is a little bit of buzz sound. We'll try to rectify it in the following classes. Darsan has not got it correctly. Okay, and Rosni also has not gotten correctly. And okay, now so I write the correct answer also then. So this is aluminium. Whenever you break aluminium, we break aluminium as Al3+. Aluminium will always get 3 plus charge. But the point here is how many aluminium you got? You got how many aluminium? You got 2 aluminium. So 2 aluminium. Then this is cation then plus. This is SO4. This is sulfate. Right? So whenever you break this, you will get SO4. But then you should also know that sulfate carries how much charge? So sulfate carries 2 minus charge. Right? Sulfate carries 2 minus charge. But how many sulfate you got? You get 3 sulfate there. So 3 here. Understood? This is the correct breaking. Whoever has gotten it, they have done a good job. Okay. Whoever not gotten corrected, try to understand now what I am doing. So aluminium breaks into Al3+. This we have to memorize. Charge we have to memorize. Then only we can write correct answer. So aluminium getting 3+. Sulfate getting 2 minus. How many? 2, 3. Now you find total charge on total cation. 1 aluminium bearing 3+. So 2 aluminium will bear 6+. Right? So the magnitude is 6. 1 sulfate bearing how much charge? -2. So 3 sulfate will bear how much charge? -6. Magnitude wise 6. Both charges are same. Both magnitude are same. So the N factor becomes 6. And one more we'll try now. N the N factor of NaNO3 now. Yes, Sanjay Madhavan has got correct, Darshan has got correct. No, Nitesh Jain is incorrect. Srinivas has got correct, Satyanarayan has got correct, Abdullah Khan is incorrect. Narayan Krishnan, you have to write the N factor, Narayan. You have to write N factor. Guru has got it correct, Darshan has got it correct, Arjun has got it correct, Santoshi has got it correct, Narayan Krishnan also has got it correct, Kusma has got it correct. Good. Nikhil has got it correct. Okay, so the N factor here to break this Na plus, remember, and the other one is nitrate, that is NO3 minus. Total charge plus 1, total charge minus 1, and factor is 1. So now we take this N factor to the option D. Now here, option D. Okay. Now talking about option D, 1 gram equivalent of NaNO3. So the heading they are saying is 1 gram equivalent of NaNO3. My job is to find Na plus. To find Na plus will come here. So you need for molecules, you need moles. So you should be able to convert gram equivalent into moles. Do you have a formula? So if you look like this point here, then you will find that there is a formula. Moles equals to gram equivalent by N factor. So all this we have done just to find this value. Find what? Find N factor. So that I can find moles. So now I will write here. Moles equals to gram equivalent how many? 1 by N factor of NaNO3. Just now you have calculated NaNO3 and factor is 1. So by 1. So how many moles? 1 mole. So how many molecules? Na molecule of NaNO3. From NaNO3 molecule, how many Na plus? 1 molecule of NaNO3 contains how many Na? 1 Na. So same value, Na ions of Na plus. Now this question answer is which was correct option. So they were saying about this. I should getting these many ions. I should be able to getting 0.1 Na ions of Na plus. Which option is giving me this value? Option A is giving me 0.2 Na, which is not equal. Option B is giving me 1 Na, which is not equal. Option C giving me 0.1 Na, which is matching. And what about point D? Option D, which is also not matching. The correct option is option C. Understood now? This is your third question. Okay? Yes, Vishal has got the correct answer now. Okay, so now we'll do question number 4. If you have doubts on question number 4, you write in comment box question number 4. Question number 4. Do you have doubt on question number 4? Question number 4. Do you have doubt in 4? If not in 4, then 5. Okay, and good. Question number 5. Now we are moving to question number 5. Hema Mali did not get the correct answer. Guru Prithvi, question number 4. Do you have doubt or not? Okay. For Guru, I am telling number of oxalic acid molecule in 100 ml of 0.02 normal oxalic acid. So now they are saying, okay, so we'll solve that also. Can I give you a hint? I'll give you a hint, you try, okay? I'll give you a hint for question number 4, you try, it is easy. What they are saying? They are saying ml and normality. ml and normality. So, gram equivalent, there is a gram equivalent. Gram equivalent equals to normality into volume. Normality into volume. So normality is given in 4th question. Volume is given. You find gram equivalent. Once you know gram equivalent, you find moles. To put gram equivalent divided by N factor. Now what is the oxalic acid formula? Oxalic acid formula is H2C2O4. 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 This gives how many H plus? It gives gives 2H plus, so the N factor is 2. Once you know the N factor here, put N factor here, you will get moles. Once you get moles, you go to molecules, atoms like this. Easy. Okay, try like this. Darshan has got us question number 5. Okay. So now we'll solve question number 5. Hydrogen and oxygen combine to form H2O2 and H2O containing 5.93% and 11.2% hydrogen respectively. The data illustrate. Okay, so there are 3 laws. First one is law of constant proportion. Law of constant proportion. Second one is law of multiple proportion. And third one is law of reciprocal proportion. Now I'll give you an easy trick. To utilize this. Okay. So in the data, if it is given, how do I say which law is applicable? Okay. So in order to do this, I'll give you a simple trick. If they are asking, if you want to apply law of constant proportion, then only single compound is given. If single compound is given, this law is applicable. Law of constant proportion forever. It means if only H2O is any single compound, if H2O is given, in that H2O, this constant proportion is applicable. What this constant proportion says? This constant proportion says that wherever I want to form H2O, wherever I want to form H2O, from wherever I want to form H2O, whatever mass I take of H2 hydrogen and whatever mass of oxygen I take, their ratio of their masses is fixed. So I'm not going to much deep in this level, but you need to understand like this. If you want to be law of constant proportion, only single compound is given. If you want to be law of multiple proportion, then the trick here is 2 compound must be given. 2 compound must be given. If you do not have 2 compound, this law is not applicable. If you have 2 compound, then only this law is applicable. Now, law of reciprocal proportion. What they found, the record is condition. The condition here is at least 3 compound must be given. Understand the easy trick. How do I memorize this now? If you want to apply law of constant proportion, 1 compound. For multiple proportion, 2 compound. For reciprocal proportion, 3 compound you should have. Then only these laws are applicable. Now if you look at the question, what question says? 5th one. Hydrogen and oxygen combine to form H2O2. 1 compound. And H2O. Containing this data. This data illustrate. Now without even solving, you can tell me which law it is. How many compound is given? 2 compound is given. It means which law is applicable? Law of multiple proportion. Madani Hamza Imran is asking how other country student can join this. For other country student, what you can do is you can pay amount of fees whichever is required, deposit in a respective accounts, and then they will send you this photo printout scanned copy of all this. Then you can join the proper course. Understand? This is for other country students. Okay. Now, so understand this question now. number 6. If you doubt, so tell me. 6, 7. Now we'll increase our speed, okay? 7. Question number 7. Each question I'll give you half and half minutes so that you can tell me, okay? Question number 7. Question number 8. Question number 9. Seventh answer is B. Yes, seventh answer is B. Correct only. Correct only. 8. Question number 8. Question number 8. Question number 8. Eighth answer is A. Yes, eighth answer is A. Correct only. Eighth answer is A. Correct only. 9. Question number 9. Question number 9. Do you have doubt? Question number 9. Darshan, do you have doubt? Question number 8. Okay. Number of gram atom in one hydrogen atom of an element. This I told you. Gram atom is same as moles. Gram atom is same as moles. Gram atom is same as moles. One hydrogen atom of an element. Number of gram atom. They are asking is how many moles are present in 1 gram of hydrogen atom. Understand? They are asking how many moles are present. In 1 hydrogen atom element. Understood now? So you try that in back again. Okay, question number 9. Okay, question number 7 is also doubt. What is correct for 10 gram of CaCO3? 10 gram of CaCO3, 10 divided by 100, you will get moles. Correct? 10 divided by 100, you will get moles. Then it contains 1 gram atom of carbon. Basically the point here is whenever these all options you have to go. All options. You can't simply take to solve with one option. You have to verify all 4 options. Question number, this is question number 7. Okay. First we'll find moles. Moles equals to 10 by given mass by molar mass. Molar mass of CaCO3 is 100. That also you should memorize. How do I memorize? Ca plus C plus 3 oxygen 40 plus 12 plus 3 into 16 will get 100. So how many moles? 0.1 mole. Okay. It contains 1 gram atom of carbon. No. This is 1 mole of CaCO3. How many moles of carbon it contains? It contains 0.1 mole of Ca. It contains 0.1 mole of carbon. It contains 0.3 mole of oxygen. This mole is also equals to gram atom. In the first class only I told you, gram atom of carbon. Then it contains 0.3 gram atom of oxygen. This mole is equals to what? 0.3 gram atom of oxygen. So second option is correct. It contains 12 gram of calcium. It contains this much moles. Can you find mass? 0.1 into 40 gram of calcium. Because calcium atomic mass is 40. So how much mass? 4 gram of calcium. It refers to 0.1 gram equivalent. I got moles. What is the N factor of CaCO3? Tell me now. This is an important question. N factor. Who will tell me the moles? N factor of CaCO3. N factor of CaCO3. Tell me fast. N factor of CaCO3. Guru also correct. Okay, good, good. Now you see, n factor is 2. Why? Because you will break into Ca2 plus CO3 2 minus. Why I did n factor? Because in option D they are saying it refers to 0.1 gram equivalent. Gram equivalent equals to moles into n factor. Gram equivalent equals to moles into n factor. Moles how many? Gram equivalent equals to moles 0.1 into n factor 2. N factor is 2. So how much? 0.2 gram equivalent. So that is why option D is also not correct. Which option is correct? Option B is correct. Okay? Done. Now question number 9. If you have doubts to write question number 9. Question number 9, if you have doubts, you write. No doubt, okay. Question number 9 B is correct, yes, Peter. Okay, question number 10. Now we will move it to 10th. Question number 10. If you have doubts, question number 10. Question number 10. But Guru, you are not memorizing things. Question number 9 is easy. Okay, so I'll tell you a hint. Okay, you try again. Out of the following, the largest number of atoms are contained in. So they are asking atoms. This point they are asking. So what you should do first? You should get molecules, but you can't have molecules until you have moles. So in all 4 options of question number 9, you please find out moles. Correct? So moles formula also I given you. Once you know moles formula, convert into molecules, convert into atoms. Easy. Yes. Okay. Tenth question already I solved in the class. Remember last class I have written here heated, strongly heated. Remember? So 10th question is done. Yes, Anand, you are correct. Okay. 11. Question number 11. Question number 11. Question number 11. Okay, Arjun Ravi has down question number 11 and 12. A sample of AlF3 contains 3.0 into 10 power 24 F minus I in the number of formula unit of this. Okay, so we'll erase this now. Okay, now in this question what they are doing is they have given you this value. Understand? They have given you this unit. And how do I say? They are saying 3 into 10 power. This question number is 11. 3 into 10 power 24 F minus is there. What they are asking? 3 into 10 power 24 F minus I is there. That's what they are saying. In what? This is present in something. This is present in AL F3. Right? Right. What they are asking? They are simply asking how much they should have this. My question to you is, if I have one molecule of AlF3, how many F I will have? Tell me the rest. Formula unit, okay, this is good. Formula unit is equals to molecule. This is used only for ionic compound. Molecule generally randomly everywhere we use molecule. But if you specify molecule in an ionic compound, it becomes a formula unit. But their meaning is same, right? Yes. So our question was, if I have one molecule or one formula unit of AlF3, I have 3, right? Let's take if I have X. I have X formula unit of AlF3. How many F minus I will have? Fill this. How many F minus I will have? If X formula unit is there. So, tell me this now. Yes, 3x. I saw is the correct answer. 3x. Is because 3 times, whatever I have, it is 3 times. So I get 3x. Correct? I get 3x. Now you look at the question. Instead of 3x, they are saying this value. Instead of 3x, this value. So how much AlF3? It means how much x? That's what they are asking, x. If 3x is equal to 3 into 10 power 24, so x equals to how much? Tell fast. Tell fast, x equals to how much? X equal to 1 into 10 power 24. 1 into 10 power 24. Because 3 will go into denominator. That is the answer. Correct? Yes. So that is our question number 11. Right? Sir, question number 12 and 13. Okay, now many people were waiting for question number 12 so eagerly. Now we'll solve question number 12. Okay. Now we'll start with 12 question. Okay. All are having doubts in 12, right? Okay. All people listen up. Okay. So 12th question is, insulin contains 3.4% sulfur. What will be the minimum molecular weight of insulin? What will be the minimum molecular weight of insulin? Now, so first you write on this. They are saying something called insulin and they are saying 3.4% sulfur. Correct? Now, before you go in this case, before we go in this particular type of minimum molecular mass, minimum molar mass or molecular mass, you need to understand one point. What is that point? The point here is, let's say I want to have insulin. Okay. The insulin will be a very bigger molecule. Very bigger molecule. If I talk about something called hemoglobin, if I talk about hemoglobin, okay, 1 minute. If I have, I'll show you a photo also. Okay, 1 minute. Okay, so you zoom in here, okay. Is it visible? Zoom it here once. Okay, yes, it is visible now. Okay, now you see. This is water. This is water. Easy, are you able to see, right? This is water. What is formula of water? Water formula is H2O. Oh, right. This is a small molecule. Okay, now what happens is, let's say I want to have something bigger molecule, such as glucose, sucrose. Now you will be thinking that is only the bigger molecule. Okay, now I'll show you one molecule which you dream it like this. I'm talking about a hemoglobin molecule. Okay, hemoglobin molecule looks like how much? I'm going to zoom out. Okay. Now you see this side. Zoom in once. Okay. This is a hemoglobin molecule. This is one hemoglobin molecule. This is one hemoglobin molecule. Whereas this is one water molecule. Now you see the difference. Compared to a hemoglobin molecule, how much water molecule is? It is very, very tiny, right? So as it is very, very tiny, and if I want to write the number of carb molecular formula, so you will write hemoglobin as C2952, H4664, oxygen 832, N812, sulfur 8, Fe4. This is the molecular formula of what? Hemoglobin. This is the molecular formula of hemoglobin. Now we can't memorize this, and there is no need to memorize this also. It is just for a general knowledge. This is existing. Where? You will ask me where hemoglobin is in our blood. So this particular bigger molecule is right now flowing through my veins also, and even everyone's veins. This bigger molecule, and the water we drink, and that water is only how much? H2O. Now you see how much water is tiny compared to this one molecule of hemoglobin. First you understand the difference now. Now in order to do this particular value, I can't memorize this whole formula. Then what happens is to use this particular value, if I don't know how many exact value of atoms they are taking, I can't find molecular mass. You can find exact molecular mass by doing this. 2952 into 12 plus 4664 into 1 plus 832 into 16 plus 812 into 14 plus 8 into 32 plus 4 into 56. When you solve that, you will get exact molar mass. You will get exact molar mass. But they are not asking exact. Because to get exact, you should have molecular formula. But you don't have molecular formula. So what they do, they have calculated another method. Minimum. What is it called? Minimum molar mass. Now, my question to you is, if I want this hemoglobin to have iron element. My question, listen very carefully. My question to you is, if I want a hemoglobin to have iron element, how many iron element atom I should take? This 4 could be minimum how much? That is my question. In exactly it is 4, but minimum how much it could be? So minimum how much it could be just to have an iron element? Tell me now. Just to have an iron element, how much Fe must be there? So you write your answer once. So the answer, correct answer is 1 atom. If you write Fe minimum 1, you can write. Lesser than this is not possible. If you write 0.9, it is not correct. Dalton's atomic theory is applicable, which says that atoms are indivisible. It means you can't divide atoms. It means this is less than 1. 1 atom is divided a little bit, which is not possible. So 0.9 is not possible. Minimum how much atom you can have? Minimum you can have 1. Correct? Exactly 4 are required to have hemoglobin. But exactly they are not even asking. They are asking what? Minimum. So whichever atom is given, that atom must be 1. It means if I take one hemoglobin molecule, it should have 1 iron atom. It should have 1 iron So now, insulin, they are saying 3.4% sulfur. It means what? It means what? If I take insulin, it should have minimum 1 atom of sulfur in 1 molecule of insulin. Understand the theory now? It means if you have just to have sulfur, you should have 1 sulfur atom so that sulfur is present in a insulin molecule. Then what happens? It means this line you have to read. You will read like this: 100 gram of insulin must contains 3.4 gram of sulfur. 1 atom equals 1 molecule. So Na atom equals to Na molecule. It means mole of sulfur equals to moles of insulin. The same thing here also. If you take 1 here, then what you will write? Moles of hemoglobin equals to moles of iron provided 1 iron atom, right? So here 100 gram of insulin equals to 3.4 gram of sulfur. It means moles of insulin. Listen very carefully. Moles of insulin equals to moles of sulfur because 1 molecule has 1 atom of sulfur. So what do? We divide. Why we need to divide? We want to find moles. To find moles, given mass by molar mass. But you are not writing exact molar mass. You are writing minimum. So you will write MW minimum. 100 by MW minimum equals to 3.4. But sulfur is certain. That atomic mass is certain, right? How much atomic mass of sulfur? 32. So MW minimum equals to 32 into 100 by 3.4. If you solve this, you will get somewhere answer is 941. Duration of this class will be 1 hour 30 minutes. Satyanarayan. Okay. Question number 13. If you doubt question number 13, tell question number 13. 13, then 14. Which question you have doubt? Okay, 13 doubt for Nitish. Nitish has a doubt in question number 13. Okay, so we'll solve 13 also here then. W1 gram of an equivalent combines with oxygen forming FW2 gram of its oxygen, the equivalent weight of its element. Okay, this question will solve, not here. 1 minute. This question will solve in this chapter. 13 question will solve in redox reaction. Okay? So you give an heading in the module in your handbook. The 13 questions are will solve in redox reaction chapter. There is a redox reaction chapter, right? In that we'll discuss this question. Okay, I need to teach some concept of that. 14th also same. 14th also will solve in that particular chapter only. Okay. Now 15 will solve. 15. Do you have down with 15? 15. 15, question 15. Question 15 we have now. 16. 14 and 13, Satyanarayan will solve in redox reaction. Okay, 17. Question number 17. Now we have shifted to page number 6. Question number 18. number 18. Okay, 17 there is a doubt. Arjun Ravi has a doubt. 17. 20 gram of an acid furnaces 0.5 mole of H3O plus ion in aqueous solution. The value of 1 gram equivalent of the acid will be. So, 20 gram of an acid furnaces 0.5 moles of H3O plus in the aqueous solution. The value of 1 gram equivalent of acid will be. So what you will do? Okay, I will erase this. Gram equivalent equals to moles into and factor. Okay, so we'll do like this. 20 gram by molar mass equals to 0.5. So molar mass equals to 20 by 0.5. Easy. 18. Question number 18. Tell fast. 18. Question number 18. 18, 19. 18, 19. 19. Question number 19. 20. Question number 20. 21. Comment fast. Comment fast. If you have doubts, comment fast. 20, 21. 21 you have doubts. Okay. 21 question is good question. We'll solve 21. We'll solve 21 now. Okay? Okay, 21. If the molecules are removed from this, then the number of moles of H2O also full. So question is this. Left moles. Correct? Left moles they are asking. Left moles equals to what? Initial moles minus what? Tell me now. What should I write after minus? Initial moles minus what? Who will tell me? Initial moles minus what? Not audible. It's audible now, right? It's audible or not? Not limiting reason. No. There is no reaction. Okay, one good doubts you have written here. Limiting reagent is only used when reactions are there. Is there any reaction? Okay, so now initial moles minus removed moles. Then only left out moles. Or final moles equals to initial moles minus change. Understand? Left moles equals to initial moles minus removed moles. Okay. Okay, so now how many initial moles are there? So molecules are removed from 98 milligram of H2SO4. Initially how much gram was there? Initially 98 milligram. So 98 by 90 given mass by molar mass. But then there was one important trick. I told you that both unit must be same. This is in milligrams. into grams. Now this is initial moles minus audible but can't hear. Now it is audible or not? Right, it's audible, right? Swami, can you hear me now? Swami Goda. Roshni is also saying it is not audible. Is it audible now? Okay, meanwhile you do solve this. Yes, sir. Not audible? Okay. It's not audible. Okay, we'll do some correction. Okay, so 98. Now we'll do removed moles. Removed moles. Okay. Okay, first, before for this, find out the n factor. Okay. Solve this question. Find n factor for, we'll solve this question later on. Okay, find n factor for K2SO4. Find n factor. Okay, so yes, 2 is correct answer. So the n factor is 2. Okay, now let's go back to our original question only. 98. Okay, this is initial moles. Now removed moles. Removed moles, they are not writing in grams, they are writing in molecules wise. So how many molecules are removed? 3.01 into 10 power 20 divided by 6.02 into 10 power 23. Given molecules by Avogadro number. Given molecules by Avogadro number, right? So here you get 10 power minus 3 there. This will cancel 2 times and 10 power minus 3 by 2. Correct? So we'll take as 10 power minus 3 common. 1 minus 1 by 2, which gets you 10 power minus 3 into 1 by 2, which gets you 0.5 into 10 power minus 3. Now we'll look at the option. Okay, option is there, B option. Okay, so now this is, we have done the question number 21. Question number 22. 22. If you doubt, you write question number 22. Question number 22. 23. 24. 25. Okay, 22 you have a doubt. The total number of atoms of all elements present in 1 mole of ammonium dichromate. This is easy question. What they are saying? 22. Total number of atoms of all elements present in 1 mole of ammonium dichromate. So first you need to write ammonium dichromate. Ammonium is NH. This question number is 22. NH4 plus ammonium and Dichromate. Dichromate is Cr2O7 2 minus. So if you do cross multiply, because charges are not same, so you will get NH4 twice Cr2O7 ammonium dichromate. Now they are saying in 1 mole. In 1 mole. So in 1 mole, how many molecules? 1 mole contains Avogadro molecules. And in 1 molecule, how many are the atoms? So total atoms are 2 into 1 plus 4. 1 hydrogen atom, 4 hydrogen atoms. So total 1 plus 4 into 2 plus 2 chromium atom plus 7 oxygen atom. So if you add 4 plus 1, 5 into 2, 10. So 19. Right? So 1 molecule will contain 19 atoms. And a molecule will contain how many? So 6.023 into 10 power 23 into 19. We'll solve, we'll get an option such as 114 into 10 power 23. Okay, 23 doubt now. Okay, X gram of silver was dissolved in HNO3 and the solution was treated with excess of NaCl. When 2.87 gram of AgCl was precipitated, the value of X. X gram of Ag was dissolved in HNO3. Okay. Then, now, so you need to write some reactions now. Now this is a question of limiting reason. Question number, we are solving question number 23. Okay. While we are solving question number 23, what they are saying? X gram of Ag was dissolved. So Ag plus HNO3. It will do some reaction. This is a silver, this is a nitric acid. It's a strongest acid. Then it forms this compound. AgNO3 plus H2 gas. Half H2 gas evolved. This is one reaction. Then the solution was treated with excess NaCl. This whole sample is treated with NaCl. Excess of NaCl. One more point now. They are saying excess of NaCl. This is excess. If this is excess, it means these two must will be. In that only, you will be having limiting reagent. Correct? Yes. Then AgCl was precipitated. It means they are going to do some reaction. What is the reaction they will do? Ag, this gas goes outside. So only left out is AgNO3 plus NaCl. What is the product? Tell me the product. Yes, Satyanarayan, I will inform the timing of the next session. Why you are worried about the next session? You are not interested in the current going on scenario. Better first understand if this is important. All the sessions are important. Why you worried about the future? Be more concentrated in present, beta. Okay, tell me the product of this reaction. What is the product? Yes, not Na2, K3 there is no Na2NO3. The answer is AgCl precipitated plus NaNO3. Yes, Hemal has got correct. Okay. Now you see, what they are saying is 2.87 gram is precipitated. Now, if this is in excess, this is a limiting reagent. What they are saying, X gram of Ag. If it is X gram of Ag, okay. Now there is a moles concept. 1 mole will form 1 mole. 1 mole of silver will form 1 mole of AgNO3. Whatever AgNO3 is there, same AgNO3 is there. So whatever AgNO3 is here, that same AgCl come here. Correct? Or so I'll say Z moles of silver, Z moles of AgNO3, Z moles of AgNO3 equals to Z moles of AgCl. Understand? It means Moles of silver, what line I will write? Moles of silver is equals to moles of AgNO3 is equals to moles of AgCl. Right, this line I can write. Then I will take this and this because AgNO3 they are not giving any data. They are giving X gram of Ag. X by 108. Remember 47 Ag 108 because they won't give in the problem. So we have to memorize is equal to AgCl given mass 2.87 divided by molar mass of AgCl. So that molar mass of 108 plus 35.5 which gets you 143.5. We can solve for X. We'll go cross multiplication. We'll solve. We'll get the answer. Okay. Okay. 24. I'll write one more step. Okay. X equals to 108 into 2.87 divided by 143.5. I think this gets cancelled as such as 0.02 times. If you have doubts in 24, tell me 24, question number 24. Yes, Rosni, correct answer. 24, 25. We want to finish up this exercise today only so that tomorrow we'll start next chapter. 25, 26, 27, 28, 29, 30, question number 26. 1.35 gram of pure Ca metal was quantitatively converted into 1.88 gram of pure Ca. What is the atomic weight of Ca? So we'll write one more reaction now. Ca plus half O2 gives rise to Ca. I'll write mole of calcium equals to moles of calcium oxide. It is easy, right? So I'll write this question is question number 26. Moles of Ca equals to moles of CaO. So I'll get 1.35 by 40. Okay, 40 we can't write. 40 don't write because they are asking atomic mass of calcium only. So we'll write M. We'll write AW. 1.35 divided by AW equals to 1.88 by AW plus 16. We can able to solve now this equation or not? 1.35 AW plus 16 equals to 1.88 AW. 1.35 AW plus 16 into 1.35 equals to 1.88 AW. 16 into 1.35 equals to, we'll subtract it, 1.88 minus 1.35 AW. So AW equals to 16 into 1.35 divided by 0.53. We'll solve this, we'll get an answer somewhere 40.75. If we solve, we'll get 40.75. Okay, after 26, 27, 28, 29, 30, 31. Okay, so many people are having doubts on question number 31. Okay, question number 31 says what? 40 gram of element X combined with 16 gram of oxygen. On the basis of this information, which of the following statement is the correct statement? So what they are saying, 14 gram of element X. This is formula is H2O. The element X could have an atomic weight of 7 and its oxide is H2O. Now, basically what they are doing is, if you take one of this statement, the whole statement must be correct. If you say like this, if element X could have an atomic weight 7, you will take half of the statement correct. Then you will verify formula of oxide. Understand what I'm saying? You will verify the formula of its oxide. Okay. So now, if you take first statement, let's say first statement is correct. If element of X could have an atomic weight of 7. Okay. This question basically will solve from an equivalence concept. Gram equivalent, or we write like this. We'll write like this. X plus O gives you an XO. Okay. X plus O gives you XO compound. Now this, one of this case. Another case could be a compound of X2O or XO2. Okay, so what we'll do? 14 by atomic mass equals to 16 by, now O2 present in an oxygen gas as O2. Okay, so 16 by 32. If you equate both of them, you will find out the atomic mass. And once you find out this, then respective of that X2O, that is also important. Okay, so now to balance this whole reaction, you will do half O2, and then as there are 2X required, so you will get an X2O. Okay, it means what you will write it as? You will write 2 moles of X. 2 moles of X reacts with half moles of oxygen. Or you can write like this also. 2X plus O is equals to X2O. Then you can write 14 by 2 moles reacts with 1 mole. So 14 by AW divided by 2 is equals to 16 by 16. From here you will find out the AW. Okay. So now this is 31, 32. Before 31, 27 is also a doubt. Okay. 27 will solve. Now question number 27. 27 for this. For the reaction A plus 2B gives C 5 moles and 8 moles will produce C moles, right? This is easy question. This is a question based on limiting region. In the limiting region problem, I gave you initial grams, initial mass. Here they are giving you initial moles, right? This is what? Initial moles. So I can find what? LR directly. The reaction is balanced. You have to take care the reaction is itself is a balance only because they have given a reaction. 5 by 1. Initial moles by stoichiometry. 8 by 2 stoichiometry. This is 4. This is 5. Which is less? This is less. So this is your LR. Final moles equals to initial moles minus LR into SC. 1 mole remaining. Correct? 8 moles LR into SC. 0 mole. Initially 0 plus LR into 1. 4 moles of C will form. The person who is this person? Nikhil. Nikhil is asking what is deliquescent salt. Deliquescent salt is a salt which absorbs water. Okay. Now, this is question number 27. After 27, 32, 33. Okay, question number 33 is there is a doubt. How much water to be added to dilute 10 ml of 10 normal HCl solution to make it DC normal? This is question number 33. 33 is now how much water is to be added to dilute 10 ml of 10 normal HCl to DC normal. normal equals to 1 by 10 normality. Normality you want to make it as 1 by 10. Okay. So how much water it should be added? So we do like this. We can do final molarity equals to N1 V1 by V1 plus V2. Okay. N1 V1 by V1 plus V2. This is initial volume, this is the V2 which is added. This is volume of water. Okay. So now NF is final normality. NF is final normality. Final normality is 1 by 10 is equals to N1. N1 is initial normality which is 10 into volume 10. Okay. Divided by 10 plus V. This is what the question is. So 10 plus V equals to 1000. So V equals to 1000 minus 10. So V equals to 990 ml. Question number 34, 35, 36, 37, 38, 39, 40. Till 40, which is your doubt? Till 40, which is your doubt? Till 40, which is your doubt? Till 40. Any doubt till 40? Till 40, any doubt? Okay, so till 40 and 42, 40, 43, 40, till 43 those are statement wise questions. So if you have doubts, you can ask me in Telegram or WhatsApp also. And so if you have not, those people who have not solved this or this, you better solve it today. And if you have doubts or some problems, it will be recorded on Facebook. You can go and watch those solutions also. If you don't find a question you are having a doubt, you can ask me on Telegram or WhatsApp also. Okay, so by this our first chapter is over. In the next class we will start next chapter. What is called next chapter? That next chapter is atomic structure. Understood? The next chapter is atomic structure. So what you can do is, meanwhile, if you have finished all this, and what is homework today? So what you can do is, you can revise your 11th class atomic structure notes and you can collect all your doubts. Understand? You can read atomic structure again at your home, and you can make up a paper where you can have all the doubts based on atomic structure. When I'll teach, I'll clear all your doubts. Understand? That's how we'll go. Okay. Next class will happen at 1:30 p.m. That is for maths class. Okay. Thank you all. Thank you very much.